Hi guys, this is Mrs. Mindy, and I'm going to talk to you a little bit about force. Now, I know you did force in seventh grade also, so I'm going to kind of speed through the part that you've already had and focus on the stuff that you haven't. So remember, force is a push or pull. Here, these horses are pulling. Here's the equation for force, which you may also know as Newton's second law. So F equals ma, or force equals mass times acceleration. And the unit of force is the Newton, and that's a capital N, not a lowercase n, but a capital N. All right, so let's practice. Using the force equation. Okay, so you should be responsible for finding any of the three variables in the force equation. So you may be asked to find force or mass or acceleration, and you'll have the other two. So this is basically just algebra. But here's an example anyway. All right, an object has a mass of 15.13 kilograms and an acceleration of 16.33 meters per second squared. What is the force on the object? Okay, so what do we do every time we need to do some kind of calculation? Write down the equation. Every time. Every time. I swear it will serve you well in your science and math career. Every time. Okay, so if we're going to use this equation, we got to know what the parts are. So looking at the problem, F or force, well, that's what we're looking for. We don't know. Mass is 15.13 kilograms, and acceleration is 16.33 meters per second squared. All right, so now we're just going to plug and chug. All right, so force equals, here's the mass. So mass is 15.13, and acceleration is here, 16.33. You do some calculator work, and this is what you get. Now, you're going to have to round this to some point, and remember significant figures. There are four significant figures that you're looking for because both of your things that you're multiplying have four significant figures. So then it's sort of multiplied baby is going to have four significant figures too. So if we round this off to 4, that means we're rounding to here, and that rounds up. Okay, so that's 247.1 newtons. All right, just algebra, not that big a deal. Okay, here's a little joke for you. May the mass times acceleration be with you. Because what's mass times acceleration? Ah, yeah, okay, you got it, right, all right. Because acceleration has direction, force does too. It's a vector. So remember, the direction matters. And they can sort of cancel each other out and add together in different ways depending on the direction. Okay, net force. And net in general means the sum of the other things, the pluses, the minuses, the net force. The net force is the sum of the other forces. You will get a resultant force. Here's what I mean. So say these two soccer players are both going to kick this same ball. So they're going to kick it in opposite directions. Now, the opposite direction forces can cancel out. All right? But it matters how big they are. So here's this direction is going to the right. This direction is going to the left. So they're going to cancel out depending on what these numbers are, okay? Because they have number and direction because they're vectors. Okay, so how this works, net force. So say littler dog is pulling on the pull toy 10 newtons to the left, but bigger dog is pulling 12 newtons to the right. So then the net force, the force that results from those two forces being added together, is 12 newtons minus 10 newtons. It's the difference between them. Okay, so that's 2 newtons to the right, okay? Because that's kind of like your plus minus. It's to the right. Whatever is bigger, that's going to be left over. Okay, whatever is smaller gets canceled out. but it doesn't cancel out all of it. If they were exactly opposite, it would exactly cancel out and there would be no resultant force. There would be no net force. Okay? So they cancel out and the leftover wins. All right? So the 2 newtons is the leftover and it's going this way to the right. So that wins. Then the resultant force, the net force, is 2 newtons to the right. Okay? If they're going in the same direction, the forces add together. So these 2 guys are carrying a couch. So one is pushing 25 newtons to the right. He's kind of pushing the couch to the right. This one is pulling the couch to the right. Okay, 20 newtons. So since they're working together, the forces are going in the same direction, they add. Okay, and if you think about this, this makes total sense, right? If you're pushing this in the same direction or pulling in the same direction, then you're helping. If you're pulling in or pushing in opposite directions, you're fighting. Okay? Helping, fighting. All right? Helping adds together, fighting cancels out. Okay? There you go. Now you're going to go practice.